Welcome the candidates to this series on the Virtual Educational and Exam Preparation Hub. We wish you well on your hunt for a satisfying government dream job through successful appearance in the SSC CGL Tier I exam. This is a curated model paper for practice for the upcoming SSC CGL Tier I 2026 exam. And today we are doing a real deep dive into this material, not just, reading off an answer key.
Right, because an answer key doesn't actually teach you how to pass the test. We really need to look under the hood of this exam to understand exactly how it's built, how it tries to trick you, and most importantly, how you can beat it.
Yeah, and it's incredibly important to approach this strategically. So our mission in this deep dive is pretty comprehensive. We're going to sequentially review all 100 questions of Model Paper 05.
Exactly. But more importantly than just the answers, we're going to decode the logic of the examiner. Because, when you sit down at that computer terminal, you aren't just battling the syllabus, you are quite literally battling the clock.
Oh, absolutely. The clock is the real enemy. You have exactly 60 minutes to answer 100 questions.
Which is brutal.
It is terrifying. When you break that down, 60 minutes for 100 questions, it means you have an average of, 36 seconds per question?
Yeah, about 36 seconds. And the stakes are high because of how the scoring is structured. I mean, you gain 2 marks for a correct answer, but, and this is the kicker, there is a negative marking of 0.5 for every single mistake.
Right, so guessing wildly is actually worse than just, leaving a question blank.
Precisely. That penalty is designed specifically to punish panic. Your ultimate weapon today, for you listening, is time management and heuristic thinking. You need to know which cognitive shortcuts to take.
Okay, so by the time we finish this deep dive, you out there will have a clear mental framework for when to calculate meticulously, when to eliminate impossible distractors, and when to just cut your losses and skip ahead.
Exactly. So let's jump straight into the first gauntlet, Segment 1, which covers Section A, General Intelligence, and Reasoning. This section has 25 questions.
And reasoning is fascinating to me because it isn't strictly about what you have memorized. It's about how fluidly your brain can recognize underlying patterns and map out relationships.
Spot on. The examiner is testing your cognitive elasticity here. They want to see if you can strip away the context of a question and identify the raw logical skeleton underneath it all.
Let's test that elasticity right now. So, starting with question 1, we have a word analogy. The prompt tells us that a pen is related to a writer. And then we're asked to find what a brush is related to. The choices are painter, canvas, color, or wall.
Okay, stop right there. What's your immediate instinct?
Well, my immediate instinct when I hear the word brush is to picture a canvas or maybe paint, so color.
And that is exactly the psychological trap the test maker is setting. They are relying entirely on associative drift.
Associative drift?
Yeah, your brain naturally groups related concepts together. Brush, paint, canvas, they all live in the same mental bucket. But an analogy requires a highly specific, rigid, logical bridge. You have to isolate the first pair before you even glance at the options.
Oh, okay. So looking at just the first pair, a pen is the defining tool wielded by a writer. The relationship is strictly tool to human professional.
Right.
So if I apply that strict bridge to the second half, I need to find the human professional who wields a brush. Let's look at the options. A canvas is the surface. Color is a medium. A wall is a structure. The only actual human agent in the options is the painter, so the answer has to be painter.
Exactly. By defining the relationship first, you make all those distractors invisible. This logic holds perfectly as we move sequentially to question 2.
All right, question 2. The prompt relates cow to calf and asks what dog relates to, offering puppy, kitten, cub, and foal.
So build the bridge first.
Okay, a cow is an adult animal, and a calf is its specific biological offspring. So I need the specific biological offspring of a dog. That immediately eliminates kitten, which, belongs to a cat. Cub belongs to a bear or lion, and foal belongs to a horse, leaving us with puppy.
It sounds elementary when we speak it out loud like this, but under the pressure of a ticking clock, candidates rush. They see an animal and just click loosely related terms. Precision is speed.
Precision is speed. I like that. Let's see how that precision applies to numbers. In question 3, we have the ratio 5 to 25, and we need to apply that relationship to the number 9. The options are 81, 45, 72, and 90.
Number analogies are basically a test of your mental math reflexes. The very first heuristic, the rule of thumb you should always deploy when you see numbers scaling up in an analogy, is to check for squares and cubes.
Right, and 5 squared is exactly 25, so the relationship is just the integer mapped to its square.
Which means the answer has to be 9 squared, making it 81. Let's push that heuristic further with question 4.
Okay, question 4. We have 10 related to 1,000. We need to find the equivalent for the number 6. The options are 216, 36, 120, and 60.
Now, the scale of the jump from 10 to 1,000 tells you everything you need to know. Squaring 10 only gets you to 100. You need to cube it. 10 times 10 times 10 is 1,000.
Got it. So applying that same cubed relationship to 6, 6 times 6 is 36, and 36 times 6 is 216.
Yep, and a critical piece of advice for you out there taking this exam. Spend an hour memorizing your squares up to 30 and your cubes up to 15. That memorization turns what could be a 30-second calculation into a 2-second reflex.
I love that. Front-loading the effort to buy back time in the actual exam. Moving on. Question 5 shifts us into letter clusters. The prompt relates the cluster DEF to GHI. We need to find the match for JKL. The options are MNO, MNP, LMN, and NOP.
What's your first thought here?
Well, my visual instinct is just to say, well, it's just the alphabet in order, right? DEF, then GHI. So after JKL comes MNO. Is it really always that simple?
In this particular instance, yeah, your visual instinct is correct. However, relying purely on the visual sequence is dangerous because examiners love to stagger the alphabet.
Oh, so they'll skip letters.
Exactly. A much safer, foolproof method is to actually calculate the index shift. Map the distance between the first letters. D to G is a jump of +3 positions. E to H is +3. F to I is +3.
Ah, I see. So rather than just reading it like a song, you're actually verifying the mathematical gap. If I apply a +3 shift to J, I get M +3 to K is N, +3 to L is O, so it confirms M and O mathematically, which is much more bulletproof.
Precisely. Let's apply categorical logic now to the odd one out format. Question 6 asks us to find the odd element among rose, jasmine, marigold, and potato.
Well, this one feels like a relief, frankly. Rose, jasmine, and marigold are clearly flowers, while a potato is a root vegetable. So the potato is the odd one out.
It is a relief, but it primes you for question 7, which applies the same odd one out concept to numbers. The numbers are 2, 3, 5, and 9.
Now, this is trickier. They are all single-digit numbers. They're all positive integers. My first thought is odd versus even. 2 is even, while 3, 5, and 9 are odd, which would make 2 the odd one out. Is that the logic they want?
That is a very, very common trap. While odd-even is a valid category, the examiner is usually testing a deeper mathematical property when they present small integers like this.
So what should I look for?
Look at the divisibility. 2, 3, and 5 are prime numbers, right? Their only divisors are 1 and themselves. 9, however, is a composite number because it is divisible by 3.
Oh, wow.
Yeah, in the hierarchy of reasoning rules, prime composite status generally overrides simple odd-even status. The answer the examiner wants is 9.
That hierarchy of rules is a crucial insight. Okay, moving into series completion, we have question 8. We need to continue the sequence. AZ, BY, CX, DW, and then a blank space. The options are EV, EW, FV, and DV.
This is a classic dual-track series. Your brain wants to read it as a single flow, but you actually need to decouple the letters.
Decouple them.
How? Look only at the first letter of each pair. A, B, C, D. That is a simple forward progression by 1, so the next letter must be E. Now isolate the second letters. Z, Y, X, W. That is a backward progression by 1. The letter immediately preceding W in the alphabet is V.
So synthesizing those two separate tracks, we arrive at EV. That makes so much sense.
Okay.
Question 9 moves us back to numbers. The sequence is 3, 6, 11, 18, 27, and then a blank. The options are 38, 36, 40, and 35. When I see this, my eyes immediately go to the spaces between the numbers.
And they absolutely should. Finding the differential, or the gap, is the skeleton key for almost all number series. Let's map those gaps out.
Okay. The difference between 3 and 6 is 3. Between 6 and 11 is 5. Between 11 and 18 is 7. Between 18 and 27 is 9.
Notice anything.
Yeah, the gaps themselves are forming their own secondary sequence, 3, 5, 7, 9. Those are consecutive odd numbers, so logic dictates the next gap must be 11.
Right.
If I take the last number, 27, and add that new gap 11, I land firmly on 38.
Perfect execution. Now, apply that exact same diagnostic approach to question 10. The sequence is 1, 2, 6, 24, 120, followed by a blank. The options are 720, 600, 480, and 240.
Let's see. If I try the gap method here, the gaps are 1, 4, 18, 96. That doesn't feel like a neat secondary sequence at all. The numbers are just exploding in size.
And that exponential explosion is your primary clue. When numbers grow that aggressively, addition is off the table. You are looking at either multiplication or exponents. Let's look at the multipliers. How do you get from 1 to 2?
You multiply by 2.
From 2 to 6.
Multiply by 3.
From 6 to 24.
Multiply by 4. And from 24 to 120 is multiplying by 5. Oh, I see the machinery now. The multipliers themselves are increasing by 1 each time, times 2, times 3, times 4, times 5.
Exactly. So the next operation must be
Multiplying 120 by 6, that gives us 720.
Spot on. Let's look at the inverse scenario in question 11. The sequence is 81, 27, 9, 3, followed by a blank. The options are 1, 2, 0, and 6.
Here the numbers are plummeting. And because they are dropping so steeply, subtraction feels too slow. It has to be division. Let's check. 81 divided by 3 gets us to 27. 27 divided by 3 is 9. 9 divided by 3 is 3.
You've identified the genetic signature of the sequence. It's a constant division by 3.
Therefore, executing the final step, 3 divided by 3, leaves us with exactly 1.
Exactly.
We wrap up the series questions with question 12. The sequence is 6, 11, 21, 36, 56, and a blank. Options are 81, 76, 66, and 86.
Let's revert to our trusty gap diagnostic since the growth here is moderate, not explosive like before.
Okay, the difference between 6 and 11 is 5. Between 11 and 21 is 10. Between 21 and 36 is 15. Between 36 and 56 is 20.
And the pattern is?
The gaps are 5, 10, 15, 20. They're increasing by multiples of 5, so the next gap has to be 25. Adding 25 to 56 brings us right to 81. It is incredibly satisfying when you reveal the hidden architecture like that.
It builds tremendous confidence, which you absolutely need for the coding-decoding section. So let's look at question 13. We are told that in a certain code language, the word LMP is written as MBNQ. We need to decode how the word DSK would be written. The options are EFTL, EFTK, DFTL, and EFSL.
This looks like a direct letter substitution. If you look at the first letter, L shifts to M. That's just the very next letter in the alphabet, so a +1 shift. It shifts to BM to N, P to Q. Is a uniform +1 forward shift across the entire word.
Correct. The rule is established. Now strictly apply it to DSK without second-guessing yourself.
TD becomes FS, becomes TK, becomes L. You arrive at EFTL.
Beautiful. Question 14 introduces a different type of code. It says if A equals 1, B equals 2, or so on, up to Z equals 26, what is the sum of the position values of the letters in the word CA? Options are 6, 5, 7, and 9.
So this is mapping letters to numbers.
Right. This tests your alphanumeric mapping. The question explicitly tells you to assign numerical values based on standard alphabetical order. C is the third letter, so its value is 3. A is the first, so 1. B is the second, so 2. The critical instruction is to find the sum.
3 plus 1 plus 2 equals 6. That seems almost too easy.
The math is easy, sure, but remembering the numerical positions of random letters like S or W under pressure is not my strongest piece of advice. The moment your exam begins, use the rough sheet provided to quickly write down the entire alphabet with their corresponding numbers from 1 to 26.
Oh, wow. Before you even see a coding question.
Yes, it takes maybe 15 seconds and acts as an external hard drive for your brain, preventing silly counting errors later on.
That is a phenomenal tip. Offload the cognitive burden onto the paper. All right, let's apply our decoding skills to question 15. The word tiger is written as UJHFS. We need to find the code for lion. Options are MJPO, MJOP, NJPO, MKPO.
Map the shift again. T to U is +1, I to J is +1, G to H, E to F, R to S. It is another uniform +1 shift.
Okay, so applying that to lion. L goes to M, I goes to J, O goes to PN, goes to O. The resulting cluster is MJPO. But wait, I noticed one of the distractor options is MJLP, which just flips the last two letters.
That is a classic visual trap. Examiners know that candidates figure out the first two letters, assume they have the pattern, and quickly click the option that looks right without actually finishing the sequence. You must decode the entire word.
Moving on to a topic that notoriously causes mental blocks. Blood relations. Question 16 presents a scenario. Pointing to a boy, Sita says, "He's the son of my father's son." We have to determine how the boy is related to Sita. Options are nephew, son, brother, cousin.
Blood relations can definitely feel like a linguistic maze. The most effective strategy is the main captor method. Place yourself directly into Sita's shoes and break the sentence down in reverse. Start with my father's son. If you were Sita, assuming she is female in this context, who is your father's son?
My father's son will be my brother.
Exactly. Now substitute the word brother back into the original sentence. The sentence becomes, he is the son of my brother. Who is the son of your brother to you?
My brother's son is my nephew. Wow, breaking it down in reverse completely defangs the confusion.
Let's try it with a slightly more abstract structure in question 17. The prompt states, A is the brother of B, C is the father of A, is the sister of C. How is D related to B? Options are aunt, mother, sister, grandmother.
Okay, drawing a mental family tree. A and B are on the same generational level because they are siblings. C is the father of A. Because A and B are siblings, C must also be the father of B.
Spot on. Now integrate the final piece of data. D is the sister of C.
Since C is the father of B, D is the sister of B's father. The sister of my father is my paternal aunt. So the answer is aunt. Visualizing the generational levels makes the relationships glaringly obvious.
It really does. Let's shift gears from mapping family trees to mapping physical space with directions. Question 18. A man walks 5 meters towards the east, turns left, and walks 12 meters. How far is he from the starting point? Options are 13 meters, 17 meters, and 15 meters, and 15 meters.
Well, if I just add the distance he walked, 5 plus 12 is 17 meters,
Yeah.
and 17 is sitting right there as the second option.
And it is a massive trek.
Yeah.
The phrase, how far is he from the starting point in spatial reasoning, always implies the shortest possible distance, a straight line, not the total distance traveled. Visualize his path. He walks east, then makes a sharp 90-degree left turn to walk north. He has essentially drawn the 2 legs of a right-angled triangle.
Which means to find the straight line distance from the start to the end, I need to calculate the hypotenuse using the Pythagorean theorem. So the square of 5 is 25, the square of 12 is 144, adding those gives me 169, the square root of 169 is 13, he is 13 meters away.
Correct. And to save even more time, candidates should memorize common Pythagorean triplet sets of integers that satisfy the theorem perfectly.
Like what?
Well, 3, 4, 5 is one, 5, 12, 13 is another. If you have those memorized, you read 5 and 12 on a right angle and instantly click 13 without doing a single calculation.
That's brilliant. Let's look at angular movement in question 19. A person facing north turns 90 degrees clockwise, then 180 degrees. Which direction is the person facing now? Options are west, east, south, north.
This requires a mental compass. You start facing north. A 90-degree clockwise turn is a standard right turn that puts you facing east.
Right, and then a 180-degree turn is a complete about face.
Yeah.
It doesn't matter if it's clockwise or counterclockwise. You will end up facing the exact opposite direction. The opposite of east is west.
Precisely. Let's tackle ranking and seating arrangements next. Question 20 states, in a row of children, Gita is 7th from the left and 11th from the right. How many children are there in the row? Options are 17, 18, 16, and 19.
The intuitive rushed math would be to just add 7 and 11 to get 18.
Which is, again, the trap option. There is a rigid formula for this structural overlap. The total number of items in a row equals the position from the left plus the position from the right minus 1.
Wait, why do we subtract 1?
Because you are counting Gita's physical body twice. You counted her as the 7th person when moving from the left, and you counted her again as the 11th person when moving from the right. To find the true number of unique children, you add 7 and 11 to get 18, and subtract the duplicate count of Gita. That leaves 17 children.
That makes perfect sense. Okay, question 21 ramps up the complexity with a multivariable seating arrangement. 5 friends sit in a row. M is to the right of N. O is to the left of NP is to the right of MQ. Is to the extreme left. What is the seating order from left to right?
Look for absolutes. The prompt explicitly gives us an absolute anchor. Q is at the extreme left, so we know our sequence begins with Q.
Okay, Q is in position 1. Now I need to piece together the remaining 4 friends, M, N, O, and P. We are told O is to the left of N and M is to the right of N. That forms a solid block of 3 people. O, then N, then M.
Exactly. You've built a coherent chunk. Now look at the final constraint. P is to the right of M. You attach P to the end of your chunk, giving you O, N, M, P.
I just take that chunk and attach it to our anchor, Q. The final order from left to right is unequivocally Q, O, N, M, P.
Excellent systematic deduction. This brings us to question 22, which introduces formal logic and syllogisms. The statements are, no fish is a bird, all birds are animals. The conclusions we need to evaluate are, conclusion 1, some animals are birds. Conclusion 2, no fish is an animal. The options ask whether only I follows, only 2 follows, both, or neither.
Syllogisms always feel like mental gymnastics to me. What is the most reliable way to untangle these?
Venn diagrams. Visualizing the sets entirely removes the ambiguity of language. Let's draw it based on the statements, all birds are animals. Draw a circle representing birds and place it entirely inside a larger circle representing animals.
Okay, I got it in my head.
This visually proves conclusion I. Because the bird circle occupies space inside the animal circle, it is an absolute fact that some part of the animal group consists of birds. Conclusion I logically follows.
Now for the tricky part, the fish. The statement says no fish is a bird. So I draw a separate circle for fish, ensuring it does absolutely not overlap or touch the bird circle.
Correct. But here is the crux of the syllogism. Does the fish circle overlap with the massive animal circle?
Well, the statements don't explicitly say. A fish might be an animal, or it might be outside the animal circle, completely based only on the provided text.
Exactly. In formal logic, if a scenario is possible but not explicitly proven by the statements, the conclusion does not logically follow. Because we cannot definitively prove that no fish is an animal, based purely on the given text, conclusion 2 is invalid. Therefore, only conclusion follows.
That distinction between unproven and false is critical. Let's look at an applied logic scenario in question 23. We are given a statement from a notice board. Please book your tickets in advance to avoid last-minute rush. We have to evaluate two conclusions. 1. Advance booking can reduce rush. 2. There is usually a rush at the last minute.
This question tests your ability to identify inherent assumptions. Think about it. Why would a regulatory body put up this notice? The notice suggests an action, which is advance booking, in order to achieve a specific outcome, which is avoiding a rush.
Right.
It inherently assumes a causal link. Therefore, it logically implies that advance booking does indeed reduce the rush. Conclusion follows.
And regarding conclusion 2, you wouldn't warn people about a last-minute rush if it never happened. The existence of the warning implies the existence of the problem. So conclusion 2 also follows. The answer must be that both conclusions follow.
Spot on. Let's move to question 24, which is a mathematical intersection problem, often solved with Venn logic. In a survey of 80 people, 45 read newspapers, 30 watch television news, and 10 do both. How many do neither? Options are 15, 20, 10, and 25.
If I add the newspaper readers, which is 45, and the TV watchers, 30, I get 75. Then I add the 10 who do both, giving me 85. But the survey only had 80 people. Where is my math breaking down?
You are falling victim to the double counting trap. The 45 people who read newspapers includes the 10 people who do both. The 30 people who watch TV also includes those same 10 people. You have counted that overlap group twice.
I need to subtract the duplicate count, just like we did with Gita in the ranking question.
Precisely. The formula for the union of two sets is group A plus group B minus the intersection. So 45 plus 30 is 75. Subtract the overlap of 10 and you are left with 65. This 65 represents the total number of unique people who consume news in some form.
Now, out of the total 80 surveyed people, if 65 are consuming news, the remaining people must be doing either. 80 minus 65 is 15. 15 people do neither.
That brings us to the final question in Section A, question 25, which deals with mathematical operations. We are given an equation, 8 plus 2, 4 by 1, 5. But there's a catch. The prompt states that ln plus actually means multiply, x means subtract, bln means divide, and 1 means add. The options are 8, 10, 6, and 12.
Oh, wow. It's designed to completely disorient you. If I try to calculate this while simultaneously translating the symbols in my head, I know I will make a mistake.
Which is exactly why you shouldn't try. The only reliable method is to rewrite the entire equation on your scratch paper using the substituted signs before you do any math at all. Let's do the translation. The 8 plus 2 becomes 8 multiplied by 2, the minus 4 becomes divided by 4, the times 1 becomes minus 1, and the divided by 5 becomes plus 5.
Okay, so the translated functional equation is 8 times 2 divided by 4 minus 1 plus 5. Now I just solve it left to right?
No, that is the second trap. You must adhere strictly to the Bode-MAS rule. Brackets, orders, division, multiplication, addition, subtraction. Mathematical hierarchy doesn't disappear just because the symbols were swapped. We must perform the division first. 2 divided by 4 is 0.5.
Next is multiplication. 8 multiplied by 0.5 is 4. Our equation have collapsed down to 4 minus 1 plus 5. Since addition and subtraction have the same priority, we can just move left to right. 4 minus 1 is 3. 3 plus 5 is 8. The answer is 8.
Excellent. That wraps up our deep dive into the reasoning section. The key takeaways here are defining rigid relationships, mapping gaps, and avoiding the urge to rush mental math without writing down the structural formulas.
That was intense, but illuminating.
Yeah.
We're now transitioning into segment 2, section B, which is general awareness, questions 26 to 50. 50 marks on the line. How should a candidate adapt their mindset to this specific section?
This section requires a dramatic shift in pacing. General awareness tests factual retention. It should consume the absolute minimum amount of time in your 60-minute window. You either know who fought in a historical battle or you do not. Staring at the screen will not magically make the answer appear. You must read the question, make your selection, and ruthlessly move on. You are banking the time you save here to spend on the complex calculations in the upcoming quantitative section.
That is a harsh but necessary reality check. So let's run through these quickly, starting with history and polity. Question 26 asks, who is known as the father of the Indian Constitution? The answer is Dr. B.R. Ambedkar.
This is foundational civic knowledge. While many prominent leaders contributed to the assembly, Dr. Ambedkar was the chairman of the drafting committee. He was the chief architect who synthesized the diverse demands of a massive nation into a cohesive legal document. Examiners love this question because it tests if you know the specific role, not just the famous names.
Right. Moving to question 27. The first Battle of Panipat in 1526 was fought between Babur and who? The answer is Ibrahim Lodi. Why is this specific battle tested so frequently?
Because it represents a massive structural paradigm shift in Indian history. The first Battle of Panipat wasn't just a change of kings. It marked the definitive end of the Delhi Sultanate and the foundational genesis of the Mughal Empire in India. It is an absolute hinge point in history.
Got it. Question 28 asks for the first woman Prime Minister of India, which is Indira Gandhi. And question 29 asks, the Quit India movement was launched by Mahatma Gandhi in which year? The answer is 1942.
The Quit India movement is a favorite for examiners because it was the definitive, uncompromising mass civil disobedience campaign that demanded an immediate end to British rule. The date, August 1942, is etched into the timeline of independence as the moment negotiations shifted to absolute demand.
Hitting the polity questions now. Question 30. How many fundamental rights are guaranteed by the Constitution of India at present? The answer is 6.
Pay close attention to the phrase "at present" in the prompt. Originally, there were 7 fundamental rights. The right to property was removed from the list of fundamental rights by the 44th Amendment in 1978 and made a legal right instead. Examiners include 7 as a distractor option specifically to catch candidates who haven't studied the amendments.
Sneaky. Question 31 asks, which article of the Constitution abolishes untouchability? The answer is Article 17.
This is a highly specific, absolute article. It doesn't just discourage the practice. It strictly abolishes untouchability and forbids its practice in any form. It is one of the most powerful egalitarian statements in the Constitution.
Question 32. What is the maximum strength of the Lok Sabha as fixed by the Constitution? The answer is 552. And question 33. Who is the Supreme Commander of the Armed Forces of India? The answer is the President.
It's important to understand the hierarchy tested in question 33. The president holds the supreme command, a constitutional provision designed to ensure that the military is ultimately subordinate to civilian, democratic authority, placing the president above the chief of army staff or the defense minister.
Let's shift our geographic focus. Question 34 asks, which is the longest river in India, flowing entirely within the country? The answer is the Ganga.
The trap here is the phrasing of flowing entirely within the country. While the Brahmaputra and the Indus are massive river systems, immense portions of their lengths lie in Tibet or Pakistan. The Ganga has a course of over 2,500 kilometers primarily within Indian territory, making it the correct answer to this specific constraint.
Question 35. Which state in India has the longest coastline? The answer is Gujarat. I always instinctively think of southern states like Kerala or Tamil Nadu because they form the peninsula.
That visual bias is exactly what the test makers are banking on. While the southern states have long, straight coastlines, Gujarat's geography is highly complex, filled with massive inlets, gulfs like Kutch and Kamhat and peninsulas. If you unroll that jagged edge, it stretches longer than any other state's coast.
Fascinating. Question 36 asks which state the Tropic of Cancer does not pass through, giving the options Tamil Nadu, Gujarat, Madhya Pradesh, and Jharkhand. The answer is Tamil Nadu.
This requires a mental map of India. The Tropic of Cancer is a line of latitude that cuts roughly horizontally right through the middle of the Indian landmass. Gujarat, Madhya Pradesh, and Jharkhand all sit right across that central belt. Tamil Nadu is situated far to the deep south, practically near the equator. It is geographically impossible for the tropic to touch it.
Question 37 asks for the highest mountain peak in the world. The answer is Mount Everest. Moving rapidly into the economy section, question 38 asks what the abbreviation GDP stands for. It is gross domestic product.
GDP is the ultimate scorecard of a nation's economic health. It represents the total monetary value of all finished goods and services produced strictly within a country's borders in a specific time period. It is the baseline metric tested in almost every economic section.
Question 39. Which is the Central Bank of India? Answer: the Reserve Bank of India. Question 40. In which year was the Goods and Services Tax, or GST, introduced in India? Answer: 2017.
The introduction of GST on July 1st, 2017 was perhaps the most massive structural economic reform in modern Indian history. It dismantled a labyrinthine web of cascading state and central indirect taxes and replaced them with a single, unified, destination-based tax system. That kind of monumental policy shift is guaranteed exam material.
Now we speed into general science, which spans questions 41 to 47 and includes question 50. Question 41 asks for the SI unit of force, which is the Newton. Question 42 asks for the hardest naturally occurring substance known, which is diamond.
The context for diamond is molecular. It is incredibly hard, not because of the carbon itself, but because of how that carbon is arranged. It forms a rigid 3D tetrahedral lattice structure where every atom is strongly bonded to 4 others, leaving no weak points.
Question 43 asks for the chemical symbol for gold, which is A. This always tricks people who look for a G.
Chemical symbols are often derived from their ancient Latin names. The Latin word for gold is aurum, referring to a shining dawn. Knowing that etymology prevents you from guessing Go or G.
Question 44, which gas do plants absorb from the atmosphere during photosynthesis? The answer is carbon dioxide. Question 45, which part of the human body produces insulin? The answer is the pancreas.
Examiners love the endocrine system. Insulin is a hormone absolutely vital for regulating blood sugar levels, allowing cells to absorb glucose. It is synthesized by the beta cells situated within the pancreas. Knowing the specific gland is critical.
That ties nicely to question 50, which asks, which is the largest gland in the human body? The answer is the liver. Let's hit the physics question, question 46. Through which medium can sound not travel? The options were vacuum, air, water, and steel. The answer is vacuum.
You need to understand the mechanism of sound. Light is an electromagnetic wave. It can shoot through the emptiness of space. But sound is a mechanical wave. It is literally a chain reaction of physical particles bumping into each other. In a vacuum, there is no matter. There are no particles to vibrate. Therefore, sound ceases to exist.
Question 47 asks which planet is nearest to the sun? It is Mercury. And wrapping up the general awareness section, we have 2 static GK questions. Question 48 asks for the headquarters of UNESCO, which is in Paris. Question 49 asks where the Gateway of India is located, which is Mumbai.
UNESCO is the UN's educational, scientific, and cultural organization, and a quick historical anchor for the Gateway of India. It was erected to commemorate the landing of King George V and Queen Mary at Apollo Bunder in 1911, though completed later. Associating facts with stories helps lock them into memory.
And just like that, with relentless pacing, we are halfway through the paper. Take a breath, because Segment 3 brings us to the most intimidating part of the exam for many candidates. Section C, Quantitative Aptitude. Questions 51 to 75. 50 marks. This is where dreams are either made or broken by the ticking clock.
It is the ultimate pressure test. But here is the secret. The mathematical concepts themselves rarely exceed a 10th grade level. What makes it devastating is the time constraint. If you try to solve these using long-form textbook methods, you will fail. My promise to you right now is that we're going to break down the speed math heuristics you must calculate with algorithmic efficiency.
Let's see, these heuristics in action. Questions 51 to 53 cover percentages and ratios. Question 51 asks, what is 25% of 200? The options are 50, 40, 60, and 45.
If you write down the equation 25 divided by 100 multiplied by 200, you have already lost. Yes, the ultimate speed strategy for percentages is fractional translation. You must instantly recognize that 25% is exactly 1/4. The question isn't asking you to do complex percentage math. It is simply asking, what is 200 divided by 4? The answer is 50. It should take 2 seconds, entirely in your head.
Translating percentages into fractions is a game changer. Let's try that on question 52. A number increased by 25% becomes 100. Find the original number. Options are 80, 75, 85, and 90.
Let's deploy the fraction method again. We know 25% is 14. If an original number is whole representing 44 and you increase it by 14, it becomes 54 of its original size. So the mathematical truth is that 54 of our mystery number equals 100.
Okay, setting up that algebra, 54 times x equals 100. To isolate x, I multiply 100 by the denominator 4, giving me 400. Then I divide by the numerator 5. 400 divided by 5 is 80. The original number was 80.
That is the most elegant way to solve it. Alternatively, if your brain prefers decimals, an increase of 25% means the new number is 1.25 times the original. 100 divided by 1.25 also yields 80. Use whichever mental pathway offers less cognitive friction for you.
Question 53 is a simple proportion. If 4.6 equals x, 9, find the value of x. Options are 6, 8, 5, and 7.
This tests the fundamental property of proportions. The product of the extremes equals the product of the means, simply cross-multiply. The outer numbers 4 and 9 multiply to 36. The inner numbers 6 and x multiply to 6x.
If 36 equals 6x, then dividing 36 by 6 tells us that x must be 6, fast and flawless. Let's move into averages with question 54. The average of 4 numbers is 15. If 3 of them are 10, 14, and 20, find the fourth. Options are 16, 18, 14, and 12.
The foundational heuristic for average problems is to immediately hunt for the total sum. Averages are abstract, sums are concrete. If the average of 4 numbers is 15, their total combined sum must be 4 multiplied by 15, which is 60. That 60 is your anchor.
Okay, so the total pie is 60. I'm given 3 slices of that pie, 10, 14, and 20. Adding those known slices together gives me 44. To find the missing fourth slice, I just subtract my known 44 from the total pie of 60. 60 minus 44 leaves 16. The fourth number is 16.
Perfect conceptualization. Let's apply a different average trick to question 55. The average of the first 6 natural numbers, so 1 to 6, is what? Options 3.5, 3, 4, 4.5.
I could do the brute force addition. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21. Then divide 21 by 6 to get 3.5.
You could, but brute force takes time. Here is the elegant shortcut. For any sequence of consecutive numbers, the average is always the exact middle value. Because there are 6 numbers in even amount, the middle falls squarely between the third and fourth numbers. What is exactly halfway between 3 and 4? It is 3.5.
That is remarkably faster. Bypassing the addition entirely. Questions 56 to 60 dive into profit, loss, and interest. Question 56. A shopkeeper buys a toy for Rs200 and sells it for Rs260. Find the profit percentage. Options are 30%, 25%, 20%, 35%.
2 swift steps here. First, calculate the absolute profit margin. 260 minus 200 yields a raw profit of 60 rupees. The golden rule of profit math is that percentage is invariably calculated against the original cost price, never the selling price.
So the ratio I need is the profit, 60, over the cost price, 200. The fraction is 6,200. I can simplify that by knocking off a 0 to get 620 and having it to get 310. And translating fractions back to percentages, 310 is exactly 30%.
Superb fraction translation. Question 57 tests the inverse. An item is sold for Rs 405 at a loss of 10%. Find its cost price. Options are Rs 450, 445, 405, 500.
This wording always trips me up. It's a 10% loss. My instinct is to just calculate 10% of 405 and add it back.
Which is exactly the mathematical landmine the examiner set for you. A percentage is a relative value. It is anchored to the original cost price, which we don't know. If you lose 10% of the original value, it means the selling price of 405 represents exactly 90% of the cost price.
Ah, I see the logic. 90% of our unknown CP equals 405. Mathematically, 0.9 times CP equals 405. To isolate CP, I divide 405 by 0.9. That gives me 450 rupees as the original cost price.
Exactly. Question 58 applies a discount. A product marked at Rs 500 is sold at a discount of 12%. Find the selling price. Options: Rs 440, 450, 460, 430.
I need to find 12% of 500. Finding 1% is easy. Just move the decimal twice to get 5. If 1% is 5, then 12% is 12 times 5, which is 60. The discount is a reduction of 60 rupees. Subtracting 60 from the mark price of 500 leaves the selling price of 440.
Flawless mental math. Question 59 introduces simple interest. Find the simple interest on Rs 6,000 at 8% per annum for 3 years. Options are Rs 1,440, 1,400, 1,480, 1,500.
This is one where we just have to trust the formula, right? Simple interest equals principal times rate times time, all divided by 100.
Yes, but you can calculate it visually. You have 6,000 times 8 times 3 over 100. Mentally cross out the 2 zeros in the denominator and 2 zeros from the 6,000. You are left with 60 times 8 times 3.
8 times 3 is 24. Now I just need to multiply 24 by 60. 24 times 6 is 144, then append the 0 back on. The interest is 1,440 rupees.
Question 60 feels more like a riddle than an equation. A sum doubles itself in 10 years. It's simple interest. What is the rate of interest per annum? Options: 10%, 8%, 12%, 5%.
It does feel like a riddle because we don't have a principal amount or an interest amount. We just have the time, 10 years.
You don't need a specific principal amount if you understand the conceptual threshold. If any sum of money doubles itself, it means the total interest earned is exactly equal to the original principal. You have achieved a 100% net increase in your money.
Oh, that's the skeleton key. The total growth is 100%. If it takes exactly 10 years to achieve a 100% growth, and simple interest accrues evenly, I just divide 100% by 10 years. That means it is growing at a rate of 10% per annum. That is incredibly fast once you see the hidden mechanism.
That is the power of conceptual understanding over rote memorization. Let's move to time, work, speed, and distance. Question 61 is the classic cooperative work problem. A alone can finish a job in 10 days and B in 15 days. Working together, in how many days will they finish it? Options: 6 days, 5 days, 8 days, 12 days.
The intuitive mistake here would be to average their days, maybe guess something around 12, but they're working together, so it has to be faster than both of them. It has to be less than 10 days.
Which eliminates the 12-day option instantly. The standard architectural solution here is the fractional method. You must calculate their one-day work rate. If person A takes 10 days to do a full job, they complete 110th of the job per day. Person B completes 115th of the job per day.
So when they join forces, I add their daily rates together, 110 plus 115. To add fractions, I need a common denominator, which would be 30. That translates the fractions to 330 plus 230. Adding those gives a combined daily work rate of 530, which simplifies down to 16.
Excellent. The combined entity of A and B can complete 16th of the task every single day. To find the total time required to finish the whole task, you simply invert the fraction. It will take them exactly 6 days.
Question 62 scales this concept up. If 8 workers can complete a task in 15 days, how many days will 12 workers take? Options are 10, 12, 8, and 20 days.
Instead of fractions, use the total worker days concept. Imagine the task is a giant pile of dirt. To move it requires 8 workers digging for 15 solid days. If you multiply 8 by 15, you get 120. That number, 120 worker days, is the absolute total effort required to move the dirt. That number is constant.
I like that visualization. So the required effort is locked at 120 units. Now the scenario changes. We have an expanded crew of 12 workers. How many days does this new crew need to hit that target of 120 units? I just divide the 120 effort units by the 12 workers. That gives me exactly 10 days.
Perfectly reasoned. Now for speed and distance. Question 63. A car travels 240 kilometers in 4 hours. What is its average speed? Options are 60 kilometers, 50 kilometers, 80 kilometers.
This one is refreshingly direct.
Okay.
Average speed is simply the total distance divided by the total time. 240 divided by 4 is 60 kilometers per hour.
It is a warm-up for question 64, which tests unit conversion. Convert a speed of 90 kilometers into meters per second. Options are 25 meters, 20 meters, 30 meters, 15 meters.
Calculating this manually sounds brutal. I'd have to multiply 90 by 1,000 to get meters, then divide by 60 for minutes, then divide by 60 again for seconds. The chance of making an arithmetic error is massive.
Which is exactly why you memorize the conversion constant. To convert any speed from kilometers per hour to meters per second, you multiply the value by the magic fraction, 518.
Wait, why 518 specifically?
Because 1,000 meters divided by 3,600 seconds simplifies perfectly to 518. It is the baked-in mathematical bridge. Let's apply it. 90 multiplied by 518.
Oh, and 18 divides perfectly into 90 exactly 5 times, leaving me with 5 times 5, which is 25. So 90 kilometers, 25 meters. That fraction is a lifesaver. And if I need to go the other way from reps to kilometers?
You simply flip the constant, multiply by 185. Keep those two fractions securely in your mental tooltip.
Good to know. Question 65 is a mixtures problem. In a mixture of 40 liters, milk and water are in the ratio of 5.3. How many liters of milk are there? Options are 25 liters, 20 liters, 15 liters, 30 liters.
A ratio is just a recipe. The recipe calls for 5 parts milk and 3 parts water. To find the size of a single part, you must first determine the total number of parts in the entire mixture. Add the ratio numbers together. 5 parts plus 3 parts equals 8 total parts.
So the entire 40-liter bucket is made up of 8 equal parts. To find the volume of just one part, I divide the 40 liters by 8. That tells me that one single part is exactly 5 liters.
Now look at what the question specifically asks for. It wants the volume of milk.
Right. The recipe says milk accounts for 5 parts. Since each part is 5 liters, I multiply 5 parts by 5 liters, giving me 25 liters of milk in the mixture.
We are rolling now into mensuration and geometry, questions 66 to 70. This is an area where visual intuition fails and formulas are the absolute price of admission. Question 66. Find the perimeter of a rectangle whose length is 12 centimeters and breadth is 8 centimeters. Options are 40 centimeters, 20 centimeters, 96 centimeters, 48 centimeters.
Perimeter is the continuous line forming the boundary of a closed geometric figure. It's the fence around the yard. Since a rectangle has 2 equal lengths and 2 equal breadths, the fastest formula is 2 times the sum of length and breadth.
Execute it.
Okay, length 12 plus breadth 8 is 20. That's halfway around the rectangle. Multiply that 20 by 2 to complete the circuit, giving a total perimeter of 40 centimeters.
Excellent. Question 67 tests circular area. Find the area of a circle whose radius is 7 centimeters. Take pi as 227. Options are 154 square centimeter, 44 square centimeters, 49 centimeters, 88 centimeters.
The formula for the area of a circle is pi multiplied by the radius squared. They generously gave us 227 for pi, which is perfect because our radius is 7.
Set up the equation visually in your mind. 227 multiplied by 7 multiplied by 7.
One of the 7's in the numerator elegantly cancels out the 7 in the denominator of pi, leaving me with simply 22 multiplied by 7. 20 times 7 is 140. 2 times 7 is 14. Adding them gives 154 square centimeters.
Question 68 moves into 3D volume. Find the volume of a cube whose edge measures 5 centimeters. Options are 125, 25, 75, 150 cubic centimeters.
Well, a cube has equal dimensions all around. The volume is just the edge length cubed. 5 times 5 times 5. 5 squared is 25, and 25 times 5 is 125.
Perfect. Question 69 brings us to angular geometry. One angle of a right-angled triangle is 90 degrees, and another is 35 degrees. Find the third angle. Options are 55, 45, 65, 35 degrees.
The inviolable law of flat space geometry is that the three interior angles of any triangle must always sum to exactly 180 degrees.
Apply the law. You are given a 90-degree angle and a 35-degree angle. Add them together.
90 plus 35 is 125 degrees. That is the chunk of the triangle already counted for. To find the missing piece, I subtract that 125 from the universal constant of 180. 180 minus 125 leaves exactly 55 degrees for the final angle.
Question 70 is a rapid conceptual check. How many diagonals does a rectangle have? Options are 2, 1, 4, 3.
A diagonal is a straight line joining two opposite non-adjacent corners. Since a rectangle only has 4 corners, you can draw a line from top left to bottom right and another from top right to bottom left. That makes a maximum of 2 diagonals crossing in the center.
Correct. We conclude the math section with trigonometry and number systems, questions 71 to 75. Question 71 asks for the value of tan 0 degrees. Options are 0, 1, 12, root 3. And question 72 asks for the value of cos 90 degrees plus sin 0 degrees. Options are 0, 1, 2, 12.
Trigonometry always spikes my anxiety. How much calculation is actually required here?
Zero calculation. These questions are purely testing if you have memorized the standard trigonometric table. You cannot derive these under time pressure. You must walk into the exam room with the values of sine, cosine, and tangent for 0, 30, 45, 60, and 90 degrees permanently etched in your mind. The tangent of 0 degrees is simply 0.
And for question 72, the cosine of 90 degrees is 0, and the sine of 0 degrees is also 0. So adding them together is just 0 plus 0, which equals 0. It is intimidating notation, but functionally it's kindergarten math if you've memorized the table.
Exactly. Question 73 is elementary algebra. If by 4 equals 9, find the value of x. Options are 36, 13, 45, 32.
To isolate the variable x, I need to reverse the division. I multiply both sides of the equation by 4. 9 multiplied by 4 is 36.
Question 74 tests number theory. What is the ACF, the highest common factor of 24 and 36? Options are 12, 6, 8, 72.
I know a factor is a number that divides perfectly into another number. 24 and 36 share several factors. They're both divisible by 2, 3, 4, and 6. But the question wants the highest one. Is there a reliable algorithmic way to find it rather than just guessing and checking?
Yes, prime factorization. Break both numbers down to their molecular level. 24 is 8 times 3. 8 is 2 cubed, so 24 is 2 cubed times 3. Now 36 is 4 times 9. That is 2 squared times 3 squared.
Okay, I have the prime DNA of both numbers. How does that give me the HCF?
To find the highest common factor, you isolate the prime numbers that are common to both, and you take the lowest exponent for each. Both contain the primes 2 and 3. In our factorization, the lowest power of 2 present is 2 squared, which is 4. The lowest power of 3 present is 3 to the power of 1, which is 3. You multiply those results together. 4 times 3 equals 12. 12 is the absolute largest integer that divides evenly into both.
That structural approach removes all the guesswork entirely. And we arrive at the final math challenge, question 75. Simplify. 15 plus 5 by 2, 8, 4. Options are 23, 12, 18, 20.
We finished this grueling section exactly the way we finished the reasoning section, submitting entirely to the authority of Baut-Damaris. The equation contains addition, multiplication, subtraction, and division.
Right. Baut-Damaris dictates division first. 8 divided by 4 is 2, then multiplication. 5 multiplied by 2 is 10. Now I collapse the equation down with those new values. 15 plus 10 minus 2.
Since only addition and subtraction remain, sweep left to right.
15 plus 10 is 25. Subtract 2, and we land triumphantly on 23.
That is the end of the quantitative aptitude section. If you utilize the fractional shortcuts, the ratio translations, and the prime factorization algorithms we just discussed, you can claw back crucial minutes from this section.
We are in the final stretch now. Segment 4 covers Section D, English Comprehension. Questions 76 to 100. This is the final 50 marks. Now, English always feels a bit subjective compared to the hard math we just did.
It can feel that way, but Tier I English is remarkably rigid. It tests a combination of your innate vocabulary, which you build through reading, and your strict adherence to mechanical grammatical rules. You shouldn't rely on what sounds right. You must rely on what the rules dictate.
Let's start with vocabulary. Questions 76 to 79 cover synonyms and antonyms. Question 76 asks for the most appropriate synonym for the word difficult. The options are hard, easy, simple, light.
A synonym is a word with an identical or highly similar meaning. Difficult fundamentally means requiring much effort or skill to accomplish. The only word in the list that matches that definition is hard.
Notice what the test makers did with the distractors. Easy and simple are the exact opposite, meaning they are antonyms. They're testing if you accidentally read the prompt backward. Question 77 asks for the synonym of beautiful. Options are attractive, ugly, plain, dull.
Again, the same distractor strategy. Beautiful means pleasing to the aesthetic senses. Attractive is the direct synonym. The other three, ugly, plain, and dull, are antonyms. Eliminate the opposites to reveal the truth.
Questions 78 and 79 flip the script, explicitly asking for antonyms. Question 78 wants the antonym of friend. Options are enemy, companion, ally, partner.
An antonym is a word opposite in meaning. The core concept of a friend is a person with whom one has a bond of mutual affection and trust. The polar opposite of that is an enemy. Companion, ally, and partner are all synonyms acting as distractors.
Question 79 asks for the antonym of success. Options are failure, achievement, victory, triumph. The opposite of accomplishing a desired aim is failure. Once you spot the pattern of grouping three synonyms and one antonym in the options, the odd man out becomes obvious.
Let's move to idioms, which require cultural and etymological knowledge. Question 80. Select the most appropriate meaning of the given idiom. Once in a blue moon. Options. Very rarely. Very often. At night. Every month.
Idioms are fascinating because they sound nonsensical until you know the origin. I know the answer is very rarely, but what actually is a blue moon?
It is a genuine astronomical anomaly. A blue moon is the term used for the rare occurrence of a second full moon within a single calendar month. Because the lunar cycle is about 29.5 days, squeezing two full moons into a 30 or 31-day month happens very infrequently, roughly once every 2.5 years. Therefore, if something happens once in a blue moon, it happens very rarely.
Understanding the origin locks it in. Question 81. Select the most appropriate meaning of the given idiom to turn over a new leaf. Options: to start afresh and change for the better, to read a book, to plant a tree, to change a page.
The literal distractors here, reading a book or planting a tree, are designed for candidates who have never encountered the phrase. In the 16th century, the pages of a book were referred to as leaves. If a student was misbehaving or writing poorly, their teacher might instruct them to turn over a new leaf, meaning flip to a fresh blank page and start again with better behavior. Figuratively, it evolved to mean making a fresh start and changing your behavior for the better.
Questions 82 and 83 are spelling questions. In a computer-based test where you don't have Microsoft Word's red squiggly line to save you, how do you approach these without getting confused by the options?
The visual distractors in spelling questions are incredibly potent. If you stare at a misspelled word long enough, it starts to look correct. My absolute strongest advice: do not look at the options immediately. Read the prompt, look down at your rough paper, and physically write the word out yourself based on your internal memory. Then match your handwritten word to the options.
Let's test that on question 82. We have to select the correctly spelled word among variations of the word government. The correct answer is spelled Government.
The common error here is dropping the internal N. People pronounce it government, but if you break it down morphologically, the root verb is govern, ending in N. Then you add the suffix -uriment. Remembering the root saves you.
Question 83 asks us to identify the misspelt word among the options: separate, grammar, possess, necessary. The first option, separate, is the intended answer.
This is perhaps the most misspelled word in the English language because of how lazily we pronounce it. We say separate, tricking our brain into writing an E in the middle. The correct spelling is separate. It has a structural A right in the middle. The words grammar, possess, and necessary are all spelled correctly in the options to distract you.
Now we enter the grammar and fillers section. Questions 84 to 88. This is where structural rules dominate. Question 84. She is good blank mathematics. Options are at, in, on, with.
If you translate directly from many regional languages, in mathematics might sound perfectly logical, but English relies heavily on fixed prepositions, specific prepositional pairings that must be memorized. In standard English grammar, you express proficiency by saying you are good at a subject or a skill. It is a rigid idiomatic rule. She is good at mathematics.
Question 85. Walk fast blank, you will miss the bus. Options. Or, and, but so.
We are looking for a conjunction to connect two clauses. The first clause is an imperative command, walk fast. The second clause is a negative consequence, you will miss the bus. The conjunction or serves to introduce an alternative or a consequence of not following the command. It functions similarly to the word otherwise.
Question 86. He bought blank umbrella yesterday. Options. An A, the, no article.
This tests the indefinite articles a and an. The fundamental rule taught in primary school is that an goes before vowels and a goes before consonants. But that rule is a simplification. The true grammatical rule is that an precedes a vowel sound regardless of the actual letter.
Right, like how we say an hour, because the H is silent and it starts with an owl sound. Here, umbrella starts with a vowel sound, so it must take he bought an umbrella.
Exactly. Question 87 asks us to select the grammatically correct sentence from 4 complex options regarding time and action. The correct answer is, I have been working since morning. Why are the other options like, I am working since morning, or I has been working, incorrect?
Well, I has is a subject-verb agreement failure. I always takes have. The trickier distractor is, I am working since morning. It sounds okay in casual conversation.
It might sound okay casually, but structurally it fails the tense check. The sentence describes an action that initiated in the past, since morning, and is still actively continuing in the present moment. This specific temporal reality demands the present perfect continuous tense. The rigid architectural formula for that tense is subject plus have has plus been plus verb ending in ing, therefore, I have been working, is the only mathematically correct grammatical structure.
Question 88 brings up another notoriously tricky structure. Select the correct sentence. 1. One of my books is missing. 2. One of my books are missing. 3. One of my books is missing. 4. One of my books were missing. The correct answer is one of my books is missing.
The phrase one of is a grammatical ambush. Let's dissect it. One of means you are selecting a single item from a larger collection. Therefore, the noun immediately following the phrase must be plural. You need a collection of books to select one from.
That eliminates option 3, one of my book. But what about the verb? If books is plural, shouldn't it be are missing?
That is the trap. Books is the object of the preposition of. It is not the subject of the sentence. The true subject of the sentence is the singular pronoun one. What is missing? Is the whole pile of books missing? No, just one is missing. Because the subject one is singular, the verb must be singular, is one of my books is missing.
That breakdown is so satisfying. Finding the true subject changes everything. Let's apply rules to voice and narration. Questions 89 to 92. Question 89 asks us to change the sentence into passive voice. She writes a letter.
Let's define the architecture of voice. In an active sentence, the subject performs the action upon the object. She, the subject, writes the action, a letter, the object. To convert this to the passive voice, the object is promoted to become the new subject. The letter takes center stage.
Okay, so the sentence must start with a letter. What happens to the verb writes?
The verb writes is in the simple present tense. To build a passive verb, you must use the appropriate to be verb form matching that tense, which is, and add the past participle of the main verb. The past participle of write is written.
So the active writes transforms into the passive is written. Bringing it all together, a letter is written by her.
Perfect translation. Now let's execute the inverse operation in question 90. Change this passive sentence back into active voice. The cake was eaten by the children.
We demote the cake and promote the actors. The sentence must start with the children. Now I look at the passive verb complex, was eaten. The helper verb was tells me this happened in the simple past tense.
Exactly. So to make it active, you simply need the simple past tense form of the verb to eat.
The past tense of eat is ate. So the active sentence is the children ate the cake.
Let's shift from voice to narration. Question 91 asks for the correct indirect speech conversion of, he said, I am busy now.
Direct speech is quoting someone verbatim. Indirect or reported speech is summarizing what they said from your perspective in the present. This requires shifting multiple elements simultaneously, right?
Yes, it is a multivariable equation. First, the pronoun must shift. Since he is speaking, the internal I changes to he. Second, the tense must shift backward in time. The present tense am rolls back to the past tense was. Finally, spatial and temporal markers must shift to reflect the distance of reporting. The immediate word now changes to the distant word then.
So, applying all three transformations, I becomes he, am becomes was, and now becomes then. The final sentence is, he said that he was busy then.
Impeccable. Question 92 applies this to an imperative command. She said to him, close the door.
A command doesn't have a tense in the same way a statement does.
Correct. Imperative sentences in direct speech are translated into infinitive phrases in indirect speech. You replace the dialogue verb said to with a strong reporting verb that reflects the command nature, such as ordered, commanded, or told.
Then we connect it using the infinitive form of the action verb. So close becomes to close. Putting it together, she ordered him to close the door.
We are entering the absolute final stretch. Questions 93 to 96 cover one-word substitution and parajumbles. Question 93. Select the correct one-word substitution, a person who writes books. Options are author, editor, publisher, reader.
This relies purely on definitional vocabulary. The originator and writer of a book is the author. The editor refines it, the publisher finances and distributes it, and the reader consumes it.
Question 94. Select the correct one-word substitution, that which cannot be seen. Options are invisible, visible, transparent, opaque.
Breaking down the prefixes helps here. In means not, and visible means able to be seen. Therefore, not able to be seen is invisible. Transparent means light passes through, but you can still perceive it.
Question 95 tests sentence improvement. The two brothers help each other. The options ask if we should change each other to one another, themselves, each other's, or if it requires no improvement.
My instinct says each other. Sounds perfectly fine. Is there a technical rule that supports that?
There is a very specific rule regarding reciprocal pronouns. The strict traditional grammar rule dictates that each other is used exclusively when referring to exactly two entities. One another is used when referring to three or more entities. Because the sentence explicitly states there are two brothers, the phrase each other is mathematically flawless. The answer is no improvement.
Good to know. Question 96 is a parajumble. We have 4 fragmented sentences that we need to arrange chronologically to form a coherent paragraph. P, he planted the seed. Q, he watered it daily. R, he dug a small hole. S, a tiny plant soon appeared.
Parajumbles are tests of logical sequencing and narrative cause and effect. You must identify the initiating action. You cannot water a seed that isn't planted, and you cannot plant a seed without preparing the earth.
So the chronological anchor, the very first step, has to be preparing the ground. R, he dug a small hole. Once the hole exists, you can put the object in it. P, he planted the seed.
Now you have a timeline. What is the process that bridges the planting and the final result?
The maintenance. Q, he watered it daily. And finally, the climax or result of that maintenance. S, a tiny plant soon appeared. So the absolute logical order is R, P, Q, S.
We have arrived at the final frontier. Questions 97 to 100 consist of a reading comprehension passage. I will read the brief passage. Trees give us oxygen and shade. Their roots hold the soil and prevent floods. Because they support both people and wildlife, planting more trees is important for the future.
And the questions are straightforward. Question 97. According to the passage, trees give us oxygen and shade. Question 98. According to the passage, the roots of trees hold the soil. Question 99. According to the passage, trees help to prevent floods. Question 100. According to the passage, planting more trees is important for the future.
The overarching strategy for Tier I English comprehension is radical simplicity. Do not overthink. Do not bring in external geographical or biological knowledge. The answers are almost always literal, word-for-word extractions from the provided text. The text says, prevent floods, so you click floods. It is a test of rapid scanning and data retrieval, not deep philosophical analysis.
And with question 100 concluded, we have sequentially reviewed, deconstructed, and defeated all 100 questions of Model Paper 05. We have traversed reasoning, general awareness, quantitative aptitude, and English comprehension.
You have just witnessed the internal machinery of the exam. You have seen 100 different ways your knowledge, your speed, and your psychological resilience will be tested. But the ultimate value of this deep dive isn't just knowing the answers to these specific questions.
Right. What is the true takeaway for the candidates listening?
The real question you must ask yourself right now is, which of these 4 sections made your heart rate spike the most? Which concept caused that fatal split second of hesitation? Was it the syllogism Venn diagrams? Was it the fractional percentage conversions? Was it the tense shifts in passive voice? That split second of hesitation is not a failure. It is a diagnostic tool. It is your exact roadmap for tomorrow's study session. Attack your hesitations until they become reflexes.
Thank you for watching and following the winning strategies to solve various types of questions in all sections. If you enjoyed this presentation and found it useful, like it, share it with friends, and consider subscribing to our channel, Sphere.
Good luck.